this time one thing has to be noticed is it doesn't start from 0 right away, it starts from 90. So there is a gap in the data. If we draw an axis here, so since we're going to start from 90, so we can start from 90 right away if we give a broken line here like this. So this represents that there has been a break in the data, and from 0 we can right away start from 90. So we can just write this as 90, so that when we need 230 we can do 90, 100, 110, 120, 130, 140, 150, 60, 170, 180, 190, 200, 10, 20, 30. So in that way, so from 90 to 230 this can be done very easily. So the labeling of the x-axis is going to be time this time. The labeling is always the data, so this is the time in minute. The y-axis will always be frequency density, FD. So when we draw a histogram, the first thing that we need to know is the frequency density. Frequency density is frequency divided by class width. So since there is a data here again, so it will be 139.5 minus 89.5. We can just subtract it. 139.5 minus 89.5, or we can just do 139 minus 90 plus 1, the shortcut method. So this is 50. So 8 divided by 50. Then we have frequency is 10 divided by class width is 149.5 minus 139.5. Because of the continuity correction, there is a gap in the data here. So 149 minus 140 is 9 plus 1, 10. Then we have 10 divided by 159 minus 150, which is going to be 9 plus 1, 10 again. Then we have 169, this is again 4 divided by 10. Then we have 4 divided by 10. Then we have another 4 divided by, let me check this one, 229 minus 180 plus 1. This is 50. So let's calculate this. 8 by 50 is going to be 0.16. This is going to be 1, this is going to be 1, this is going to be 0.4, this is going to be 0.4, and 4 divided by 50 is going to be 0.08. So the height of the histogram is going to be very small. We better take something as 0.1, because the highest we need is 1. So we can consider this as 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and we have 1. So 90 to 139 means 90.5. So just, it doesn't have to be that accurate. So before 90, this is 90.5, and 139.5 is going to be 90, 100, 110, 120, 130, 140. So this is going to be pretty big. So 139.5 is going to be near to 140. It doesn't have to be that accurate. And the height is going to be 0.16. So this is 0.1 and this is 0.2. So 0.16 is going to be around here. Remember, the one that I'm drawing, because of this, it's not going to be that accurate, but it is going to give you an idea of what it's going to be like. So this is roughly 0.16. So 0.1, and we have another 6 here. The next one is 140 to 149, meaning 139.5 to 149.5. So this is 139.5 and this is 150. So 149.5 is somewhere around here, and the height of the building is 1. So we go up all the way to 1. So all the way to 1. All the way to 1. The next one is 149.5 to 159.5. So this is going to be 160. So 159.5 is here. This is also going to be 1. Now we have this up to 169 point, so it means 170, and this height is 0.4, so 0.4 is this. Then 179.5, which is 180, and this is also 4. Then we have this 229.5, close to this. This is 0.08, which is going to be less than 1. So this is the histogram. One thing you might do to add a finishing touch is when you draw a histogram, after that you can shade your histogram so that it stands out, just to give it an idea so that it doesn't blend with the graph paper, just to give it a shading. Now don't spend too much time shading, just a rough idea. Remember, when you draw the histogram, we need the label axis. This is very, very important.